Hello, good afternoon, good evening for everyone in Asia, and good morning to everyone from Europe. Slides, please. Okay, yeah, thank you for joining us. Today we're going to talk about how to bridge digital device using the new age satellite technology. My name is Harsh. I'm based in Singapore and I look after the fixed data business for SES in Asia. And I'm joined with my colleague from Down Under, Rob Stojanovic. He's based in Perth and he's looking after the new age O3b Empower constellation solution and design.
Hi, everyone.
Next slide, please. Yeah, when we talk about Asia Pacific, this is probably the growth engine for the world in terms of digital inclusion projects. And why? Because 50% of the world's population, to be precise, about 4.5 billion people live in APAC. And there are a lot of population which is, you can see almost 50% of that population do not have access to affordable means of communication. And there are still a sizable population which is outside the mobile coverage as well. When we talk about digital inclusion projects, number have taken years, and satellites have continued to play a crucial role in delivering these projects and bridging the digital divide. If I name a few, Digital India from the Indian government, DICT in Philippines, MCNC in Malaysia, and Bhakti in Indonesia are some of the examples that come to our mind. Not only these, but also satellite to deliver digital inclusion projects. Next slide, please. And in terms of Asia Pacific, when we talk about the satellite growth and demand, you can see from this chart that today the satellite backhauling market is about $1 billion cumulatively, and it's in the next 7 to 8 years it's projected to grow to 2.8 billion. So it's almost 3 times of the current market size, and it will continue to grow at 11% CAGR, which is the highest across the globe. Next slide, please. This needs no introduction. Satellites play a crucial role. Satellites have been used as a means of last resorts by telcos and mobile network operators to deliver connectivity to very, very remote areas, and where they've continued to rely on terrestrial infrastructure in urban and semi-rural areas. But as we go along, and Rob will share much more details about the emerging technologies, including SES, where the satellites could play a role even in semi-rural and urban areas. So just a bit about SES. What does SES do? So firstly, SES is a managed data network service provider across the globe, and we have at the back end of our the transport medium that we use our satellites. In our video, including the traditional wide beam geo satellites that you are aware with, but also medium Earth orbit constellations which deliver high throughput and low latency services. Who are our customers? Majorly telcos and mobile network operators, ISPs in emerging parts of the world, who we help deliver 3G and 4G services in remote areas. And as we speak, we are also starting to do pilots How does SES differentiate from rest of the world? We are not just a satellite service provider. We ensure that we build, invest in ground infrastructure, and offer end-to-end managed service to our customers to support their rollout. And as part of our partnership with Microsoft, we are also extending cloud connectivity to our customers as a value add. Next slide, please. And in terms of our assets, we have 54 wide beam satellites that are in various orbital slots. Three of these satellites are high throughput satellites, or in the satellite world, we call them HTS. And then a unique product in our portfolio is the medium Earth orbit high throughput satellite, which is the O3b constellation. Today, we have 20 of these satellites orbiting across the globe in an equatorial orbit, where we are providing services, high throughput and low latency services to mobile network operators. And what we are very excited to talk about today is about O3b Empower. So O3b Empower is the next generation medium Earth orbit constellation that is getting launched by the end of this year and will be in service next year, which we will focus our discussion towards. Next slide, please. So when we talk about orbits, I mean, I've talked about GEO, there is another orbit, LEO. So these are nothing but the distance from the Earth's surface. So GEO satellites have been traditionally used. These are at 36,000 kilometers from the Earth. They have a very, very large view of the Earth, pretty much theoretically 3 satellites can cover the whole globe. But they have an advantage of the wider coverage, but do have a limitation in terms of throughput it can support. The other advantage with GEO satellites is the relative movement of the satellite versus the rotation of the Earth is synchronous. So you can live with a stationary and to the orbits which are closer to the Earth, which are medium Earth orbit. These are 8,000 kilometers from the Earth, and physics remains the same. 8,000 versus 36,000 kilometers. The latency is 1/4 that of GEO satellites, but they do have, but it is lesser than the GEO satellites. The power is much more, and we can deliver multi-Gbps links on medium Earth orbit with a latency of below 150 millisecond, which is similar to long-haul fibers. And when we come to the low Earth orbit satellite that you might have heard about from other operators, obviously they're even more closer to the Earth's surface. The latency is between 50 to 100 millisecond round trip, but they have a very, very restrictive view of the Earth's surface. So they have to have thousands, hundreds and thousands of satellites in their constellation to put together a global service. It would require a huge amount of infrastructure on the ground in terms of gateways, and the remote terminals are also limited in terms of throughput it can support. So what SES felt was, SES was anyway, I mean, in the GEO fleet, we had more than 30-year legacy. We wanted to build a non-GEO constellation. We looked at the best of GEO and looked at MEO as the sweet spot, which delivers the right latency and throughput. Next slide, please. So how do we deliver services to the mobile network operators? So there are 3 buckets that we put these requirements in. The first one is what we call the core network backhaul, where the country, let's say an island in the Pacific, does not have very reliable connectivity on fiber, and they want to build a backup or a load sharing network on satellite. Their core is delivered a multi-Gbps circuit using medium Earth orbit satellites. And this is pretty much what we're doing with number of mobile network operators in Pacific region, mainly If I say Digicel, Telecom Cook Islands, Timor Telecom, Vietel Group, Telemore, these are all our customers which are using the core network backhauling product. When we come to the aggregation part, which is the second where we can deliver 50 to 500 megabits of connectivity. This is something that is very effectively being delivered to Telenor Group, both in Myanmar and Pakistan. And lastly, when we come to the excess backhauls, which are really single site tower backhauls, where we could deliver 2 to 50 megabit using a single remote terminal at one site. And there are a number of examples to show. Maybe I'll run into just a couple of case studies to give you some examples. Next slide, please. Yeah, so this is an example of bucket 3, where we are delivering a tower site backhaul. This is for a customer called Teleglobal in Indonesia. Teleglobal is our partner who is in return to, providing services to Bhakti. Bhakti is the USO agency of Indonesia. As you may all know, Indonesia is very challenging geography, 17,000 islands, a number of islands do not have terrestrial connectivity, and satellite is the only way to reach population residing on those locations. So Bhakti went on a very, very ambitious project to deliver services to these tough regions. SES was chosen as one of the winners in this project, and we delivered as part of phase 1 about 4 Gbps of capacity, which also included us building 2 gateways in Jakarta. And we're delivering today this service to about 1,200 remote sites spread across Indonesia. As we speak, phase 2 of this project has been awarded earlier this year. SES is again part of the awardee list, and we are now rolling out this network for phase 2. And Bhakti but has continued to show huge light, and we expect phase 3, phase 4 also to come in. Next slide. And next slide talks about bucket 2 that I talked about, aggregated backhauls. This is with Telenor Myanmar, where we are aggregating a number of eNode B sites into a single cell site. Telenor Myanmar had a unique challenge where in northern Myanmar, they were struggling to roll out LTE services, and the existing satellite technologies that they have were not adapting to the usage. And they had a very unreliable fiber and microwave network to deliver services to these sites. So they aggregated about 6 eNode Bs into a single cell site, where we delivered our MEO service using O3b. And this service has been operational for now 4 years now. And Telenor has continued to grow capacity with us on this, and we are very happy to say that the KPIs and performance that we have delivered on satellite links not only matches but exceeds the terrestrial services. And similar case is in the Gilgit region in Pakistan as well, where we are delivering aggregated backhauls. Next slide, please. Now we'll shift gears and talk about really our journey on the medium Earth orbit constellation. So really O3b, when it was started by a Silicon Valley entrepreneur. And he looked at that satellite was the right technology to deliver services into very tough regions, but it suffered from some of the entry barriers, which were latency, high cost, and limited throughputs. So with O3b, we could address those entry barriers. 2009 was the time when O3b got really formed. I joined O3b in 2013. So I was there at the start with Rob as well. At those times where we didn't have satellites, and it was more of PowerPoint presentations. But since then, we have taken long strides. 2014 is the time when O3b started services. And now the O3b services have been there for more than 6 years. So we have a lot of good legacy behind us in terms of delivering this technology. O3b Empower is built on the existing O3b constellation, which Rob will talk about. Along the way, in 2016 or 2017, O3b was acquired by SES. SES was a much larger company which was looking to foray into non-geo satellites, and they looked at O3b, which was a functioning company, an operational company. So they bought O3b and really paid a premium to all the minority shareholders. Since then, O3b Empower has been funded. It's a fully funded constellation, $1.5 billion project. The satellites go up end of this year. The first launch happens end of 2021, and we launch commercial services in half of 2022. And there's a number of firsts that we are going to do and with O3b Empower. So with that, I will hand over to my colleague Rob to talk about the exciting stuff. Rob?
Thanks, Harsh. So good evening, everyone. So I'm going to talk about our O3b current constellation. It was one of the world's first NGSO satellite constellations to deliver a commercial service. We started off with a few launches, and currently we now have about, we have 20 satellites in orbit. Out of those 20 satellites, not all are used. We do have in-orbit spares, and we provide a worldwide coverage between plus and minus 45 degrees latitudes continuously around the globe. Now, because of our orbit of 8,062 kilometers, we're roughly 1/4 the distance when compared to a geostationary satellite. And therefore, our latency is also less by 1/4. So we see typical satellite latency figures of about 150 milliseconds. Each of the current satellites today uses a spot beam technology. So we have 10 spot beams available per satellite, and each of those spot beams, we can position where we need to. And our current throughput is up to 1.6 gigabits per beam, okay, and then times 10 beams per satellite, and times the number of active satellites we've got in orbit and in use today. These are satellites and these spot beams all connect back into the SES regional gateways. We've got 8 gateways scattered around the globe. In this region, we have a gateway here in Perth, where I'm located, and we have one in the Eastern Australia, just outside of Sydney. And then Hawaii is also serving this region as well. And these 3 gateways, typically serve these or the satellites that are within this region and the beams that we can position. Next slide, please. So when it comes to Empower, we're going to do things slightly differently. We'll still be operating in the MEO orbit, so at 8,062 kilometers. We'll interdisperse the Empower satellites with the existing O3b satellites, and we'll effectively run 2 MEO constellations simultaneously. We will be launching in groups with the Empower satellites, so we'll be going from 6 satellites to provide first worldwide coverage, and then complementing that with 9 and 11, with a total of up to 11 satellites. And that is just to bring more capacity into the constellation. We're going to do, when I say we're going to do things differently. So where we've got a beam of 700 kilometers in diameter with the current O3b constellation, we're going to go down to a smaller spot beam, about 250 kilometers in diameter. And what this means is that we're able to then allocate a separate spot beam for every user terminal. And because the satellites, the Empower satellites, are fully digital, we're able to allocate resources specifically for that particular service. And that can range from anywhere between 50 megabits all the way up to about 10 gigabits, depending on the terminal size. But more importantly, we no longer have to rely on the SES regional gateways. We will still be deploying our own gateways for both the O3b Classic constellation and the O3b Empower constellation. But we're now able to actually implement customer gateways. Maybe there's a need for data connectivity to remain within a country, the sovereign data, and we are now able to deploy an in-country gateway, an in-country MEO gateway. Next slide, please. So as I mentioned, each of the satellites are fully digital. We're moving away from reflector-based technology on board the satellites to a flat panel phased array antenna. And this is extremely important for us because we have quite a large number of spot beams available to us. It's almost up to 5,000 beams. And being a flat panel phased array antenna and a fully digital payload, we're now able to connect any beam to any beam. What this can mean is that we can now deploy those domestic gateways, as I mentioned. We can also connect terminals to other terminals, and in future releases, we're looking at building out multicast capability for each of our services. The throughput, very scalable, and is dependent on the actual service requirements for each of the terminals or each of the customer requirements, and it's very scalable. So we're able to change the throughput on each of those beams or each of those services as we need to. We're also no longer constrained by a fixed forward to return ratio or download to upload ratio. We can have this very scalable as well. Okay, and as mentioned, we will be launching at the first group of Empower satellites at the end of this year, and we'll have the next launch early next year in order to get us to that that first group of six satellites, and then followed by 9 and a total of 9, and then a total of 11 satellites. Next slide, please. So our launch schedule is mentioned. So satellites 1 to 3 will be launched Q3 this year, at the end of this year. Satellites 4 to 6 early next year, and then followed by 7 to 9 and 10 to 11. And we're doing this just to build capacity within the constellation, but it also gives us a bit of an insurance policy as we deploy the network. Next slide, please. Okay. So I'll just wait for the animation to finish. So in order to help us with the deployment of this network, it's a very large network. We're capable of different throughputs and a very scalable network. We're building a software system around this satellite to help us manage the implementation of the services. So we're partnering with ONAP in order to provide our orchestration between our gateways or customer gateways and core networks. This is mainly used as a software interface so that we can automatically commission and implement terrestrial services in line with the actual satellite service. And essentially where we're aiming to go to here is a satellite as a service kind of connectivity, almost like it's an on-net service. So, dialing up an Empower service is easy as logging into a portal and activating the service. To help us manage all this, we're also building a new software system called Adaptive Resource Control System, or ARC. And this ties in with all of our key functions within the satellite architecture in order to help us manage this. Next slide, please. So our gateways, we will be deploying 10 gateways to complement our existing O3b gateways that we've got in service today. So in some cases, we'll be building on our existing infrastructure and expanding those facilities. In other locations, we will be actually building new teleports, new gateways to access this network. Each of the gateways will be connected to a point of presence, or a POP, and that's a major data center for connecting into terrestrial networks, submarine cables, large trunking backhaul applications. Next slide, please. So in order to help us facilitate this, we're looking at new ground-based equipment. We're developing it with our partners and with some of the OEMs in building new terminals for accessing the O3b Empower system, and that ranges from large fixed gateway infrastructure through to transportable government gateways. So a smaller gateway that can be for example, deployed in the back of a C-130. Flown to site, and then get set up within a matter of hours or a day to get up and running, and that's used for supporting, say, combat operations. We then go into our mobility and maritime terminals. So we're looking at dual band and tri-band systems that can operate both in a MEO and GEO constellation. So when we're outside of MEO service, we can actually go to a geostationary satellite, or when we're on a downtime or a low traffic, we can switch off the MEO to go to GEO, for example. This also includes a number of government mobility aeronautical terminals for ISR operations. And then we're also investing in some flat panel technology. It's an emerging technology. It's still in construction at the moment, and we hope to see those first terminals available by the time that Empower starts. And these are fixed, no moving parts, tracking antennas that have electronically steerable beams. So one of the questions that was asked about the ground segment platforms, we are developing new, or have developed new platforms in order to facilitate the Empower system, and we're partnered with both Galat and ST Engineering iDirect in order to provide those services. And essentially, it's a MEO platform that is integrated into our gateways, and then we'll provide the services to each of the user terminals in the field. And we have a range of different modem technologies that's available, and different licensing, ranging from, say, 300 megabits all the way up to just over 2 gigabits available on those modems. Next slide, please. So in terms of the coverage, we mentioned about 250 kilometer beams. So when we look at, say, an example for beam placement in Thailand, we can see, we've got a cluster of beams, each about 250 kilometers in diameter. And these are positioned specifically for each of the terminals, where when we compare this to, say, a HDS payload, which has fixed spot beams, really we just need to make sure that those terminals are located within a particular spot beam. With Empower, we position the spot beam specifically for that terminal, and we provide the capacity specifically for that terminal. And what this also means is that we're able to provide custom throughputs and different SLAs on a per terminal basis. Next slide, please. So the Empower system allows us to bring in some very unique value propositions for our business case, especially when it comes to national digitalization, where we're looking at, maybe expanding the mobile backhaul service from, say, a 2G or a 3G back network through to 4G, or we're trying to deploy or roll out a network of Wi-Fi hotspots in rural locations. Some of the challenges that we provide there is, or that we come across, and we've seen this in a number of locations, is, it's very hard to roll out a terrestrial infrastructure network, especially in very mountainous or very geographically challenging areas. And this is where satellite really comes into play. Empower especially will be very, very key to this, because we're able to provide that throughput and the latency in order to satisfy those applications. It's even like, well, as an example, 4G networks in the edge of the network, maybe microwave hasn't quite reached there, and we can advance deploy with an Empower terminal. We do have flexible commercial CapEx and OpEx arrangements with the Empower service, and we're able to provide variable speeds depending on the locations and the markets that we're being served. And more importantly, we can connect this back into a domestic network. Maybe the gateway is located right next to the core network, so that we reduce the latency and the infrastructure needed in order to deploy the network. Next slide, please. So in another case, when we're looking at rural communities or even island locations, so O3b, the current O3b constellation has been very successful in the Pacific in deploying trunk services into remote islands and connecting those islands, with a quality internet service, because we were able to provide additional capacity and latency benefits above, say, a geostationary network. We were able to very easily integrate with existing cellular networks, the mobile backhaul links, for example, being IP based, is able to seamlessly integrate, with those core networks. Okay. When we look at modernization, we're looking at very high-speed internet. Again, we've made a lot of inroads into the existing markets with the Pacific nations, with Asian nations. Timor-Leste, for example, has been a very big uptake in internet connectivity via the O3b service, where we're being able to exceed the 1 gigabits mark and provide a very high reliable service through, for example, the use of site diversity or terminal diversity, essentially where we have two terminals working as an MPLS network. So when we get rain at one site, the service will move over to the secondary site and maintain a near 100% uptime. So our customer in Timor-Leste has been benefiting from that for a very, very long time. And, within the first 3 months of operation, they had about 100% uptime. We're able to provide a very scalable network, especially with these trunk services, and we readily exceed the 1 gigabit throughput mark for these terminals and for the service. With Empower, we will be providing a CIR capable service, but we're also implementing an EIR, or an excess information rate. So being able to burst above the committed rate is something that's our customers have come back to us and asked us for. And with the Empower system being digital and flexible, we're able to provide that. Next slide, please. So at this point, I'll hand back to my colleague Harsh.
Yeah, thanks, Rob. Rob, before we summarize, I think there were some questions that perhaps we can address. So I think you talked about, the O3b Empower, gateways. You showed a slide on. What do you think plans for in-country gateways for certain countries in Asia?
Yeah, so SES is deploying our own regional gateways, and they can provide connectivity from each of the, from pretty much any country within that plus or minus 45 degrees latitude. However, we do appreciate that sovereign networks, or countries that may have a regulatory reason to keep data within the country, and there we would look at deploying a domestic Empower gateway that can provide the same connectivity as an SES gateway, but be constrained within that one country, and that will connect remote terminals back into that gateway.
Thanks, Rob.
And I think there was one.
Go ahead.
Yeah, one more question on the reliability of the satellite links, especially in Asia with rain fade. Rain fade is very important to us. It's something that is on the forefront of our minds when we're designing the services, and really looking at how this will operate, how the link will operate. So today with the O3b service, we do offer a full SLA against each of the services. We have a latency SLA, a throughput SLA, and also an uptime SLA. And I think that's very important. With the Empower system, because we have an adaptive resource control software system, we're going to be able to provide a system that can automatically maintain the SLA for each of the individual services. And this is very, very important because we're taking in the management decision to look at these links and assign resources in order to meet an SLA, rather than the customer having to design a system, on their own and operate it in order to try and meet that SLA as well.
I think there's another question on implementing satellite solutions. I mean, they have been traditionally difficult and costly in the past, and what has changed now? So, Rob, maybe if I can take that.
Sure.
Yeah. As I talked through my slide, entry barriers for satellite were, cost and throughput and latencies. With the MEO constellation, been able to break those barriers. At least the throughput and the latency barrier. I think with the cost part, things have changed on the ground infrastructure side, as well as there's a lot of innovation in the industry. Think about reusable rocket technology exists. Let's say 10 years ago, it does exist now. It saves the satellite launch cost, which in the tune of $60 to $70 million came down to $40 million. So we at the end of the day, it helps the satellite operator, and satellite operator passes this benefit to the customers. So the whole ecosystem in the satellite industry is innovating and making the cost barrier come down on satellite. What about a gate? So there's another question about a gateway in India. So in India, see, India is one of the very, very strategic market for us, for O3b Empower, very, very integral part of our success. We are working in India with ISRO, DOT, and mobile operators. Technology first has to be regulatory-wise cleared, and we are undergoing that process now. And we will, of course, the new Spacecom policies are supposed to come out, and satellite operators in partnership with the local service providers. So that is what we are working toward. So I may conclude with the concluding slide. So, in terms of our conclusion, satellites will continue to play a key to bridge digital divide and bring services to unserved and underserved areas. The new age satellites and the emerging technologies, which is GEO, HTS, both MEO and LEO, will make new business cases possible and will deliver the same quality of experience to subscribers in remote areas as in urban areas. And lastly, satellite operators like SES can't do it on their own. We will need a collaborative effort with the mobile network operator in country and the government regulator to deliver such projects. Rob, one last question, if you can take. How many antennas are used in the gateway to track satellite?
Sure. So we typically have between 4 and 5 gateway antennas, but a customer gateway or a user gateway, we would probably deploy about 3 antennas.
So if there are questions, can we wrap up this session then? So thank you all for joining us today. Hope we were in this last 40 to 45 minutes, we could give you a glimpse of what SES is moving towards and what we could do for the Asian nations, especially to deliver digital inclusion projects. Thanks for joining us today. I think you will hear, you will get this information in your mailbox, and contact point there for you to reach out to us. Thank you for joining us today.
Thank you, everyone.